Hi Year 10, welcome back after Easter break. We're going to go through electrical circuits. In this series there'll be about 10 lessons in total on electricity, and this should be a fairly new topic for everyone, but there'll be some things you'll remember from Year 7, Year 8, hopefully. So moving right along. Okay, so at this point guys, I would be asking you to draw a circle map for me. And if you're not familiar with a circle map, you're drawing the word electricity in the middle of the circle, putting two circles, and start to write some of the key terms about electricity. And if you're watching this on the YouTube video, you want to get used to the idea of pausing the video and grabbing a piece of paper, trying this out, just to see where you actually are. Because if you just copy out what I write down on the slides, there's not going to be much benefit to it. So normally when we pop around the classroom, we'd almost certainly get voltage, almost definitely get current. Someone might mention power. Okay, well, we have electricity in our home. Can we measure it? Well, one of the ways we measure it. And might even get someone remembering from Year 7, Year 8, where you would have learnt about resistance. Okay, but probably the most, and I'm going to make it really big, it is a transfer of energy. You're moving energy around electrical wires or anything conductive. It doesn't have to be wires, it can be water, for example. Now, putting this all together, because it's going to go over a few lessons for us. Now, we used to teach it, so we'd have learn about resistance and different types of circuits. But what I've found is it makes more sense to learn this one first. So, lesson number 1 will be on current. We'll learn lesson 2's on voltage, and these last two are sort of almost together. So power and resistance. Now we're going to touch on parallel and series circuits today, but we'll cover them in far more detail when we get to resistance. So if they're unfamiliar to you and you can't remember any of them, don't panic. We'll go over them in far more detail later on. This is what you are required to be able to do. You need to be able to draw and label a circuit. They might give you a 3D drawing and say turn it into a circuit. And here's this lovely term down here, standard conventions. Okay, you need to know the standard conventions. I'll go into them in some detail in a second. The one thing I need to see on your revision material is all the circuit diagrams that we use and the right version of them, which obviously is tying into circuit components over here. And like I said, we will have a look at series and parallel circuits in a bit of detail. Okay, so one of the things you're required to do in P10 is to tell me all the parts of an atom. Now, if you're watching this on YouTube video, I'll stop talking and let you pause in a second. You can pause it, come back to me, but I want you to grab a piece of paper and try drawing this out, and I'll explain why that's really important after we go through the answers. If you're going through the SharePoint with me, I'm sure you can pause it, but if you can't, then you should probably go back a slide, try and draw this diagram, and then come forward and rejoin me. Okay, so hopefully that was enough time for you to pause and have a go at it. 50-50 here. One of these is a proton. There you go. One of them is a neutron. Now, common misconception we have in electricity topics is that electricity has anything to do with the proton and neutron. It doesn't. Well, it does, but not in GCSE. We worry about that when we get to A-level physics. But the combination of the two, proton and neutron, is the nucleus. Now, the last one, the big one, the part of the electrical topic is, of course, the electron. Now, if you got all of those right, fantastic. This is the bit I was talking about earlier, what to do if you did get them all right. Nothing. You know them. If you got any of them wrong or you weren't sure, you had to guess, this is the opportunity. Draw this diagram, very, very small, on your P10 revision note. You need to start your P10 revision document now. I'm going to have lots of things to put on the next 2 lessons. And it'll help you put everything, all the really important stuff, all in one place. Okay, so these are our main 13 circuit symbols that you must know. These need to turn up on your P10 revision material, non-negotiable. Okay, so I put them together all in one sheet for you. I need to see them drawn on to your P10 revision material for when we come back, because I'm going to ask you to make circuit diagrams. I don't want to have to explain to you what each one of them are. You need a reference to look up and go, that's a closed switch. Straightforward. I know what that is. Now, if that's a closed switch, it might give it away what this one is. It is in fact an open switch. Nice and straightforward. Lamp or bulb, these are the kind of bulbs that you've seen in year 7, year 8 when you've been making little circuits. They're the filament style bulb. They're the ones that get hot if you put too much current through them. You won't find many of these in your homes anymore, but we use them in experiments because they have some lovely properties that we need, i.e. they get hot. This one down here, it might be, if we go across to the right, you'll see the battery symbol. You'll see the two symbols are fairly identical, and the battery is made up of these. So a battery is made up of lots of individual cells. Now, I'll switch over pens here. So when we draw circuit diagrams in physics, we'll often draw something like, let's put a bulb in there. Okay, nice and straightforward. Now that implies it's a cell. So this could be a 1.5 volt battery. So like a AA battery that you're familiar with. It won't be very exciting. You'll probably barely be able to see the bulb at all, but it will work. Okay. Now where this gets a little bit confusing is this symbol here. So if I drew, I'll try and squeeze it in here. Let's say I do this. Okay, I'm telling the person reading my circuit diagram that I'm using a battery. Okay, fine, that's straightforward, battery. But I haven't said how many cells it's made up of. It implies that it's 2 cells, but that'd be fine, except we often use this symbol for a car battery. Now, a car battery is nominally 12 volts. It's actually made up of 6 lots of 2 volts, so there's actually 6 cells of 2 volts each. Now, to draw that as 1, 2, 3, 4, I've lost count already, 1, 2, 3, 4, 5, 6, you can see already it's a bit of a nightmare. So we don't tend to, or we don't, draw each one of the cells out. Okay, you might normally say it's a 12 volt battery, and it might be labeled somewhere else. There's 6 cells. But all you need to know from this, guys, is this is 1 cell, this is multiple cells as a battery. So we actually name our batteries incorrectly. So a AA battery that you call a AA battery is actually a AA cell. But don't try and correct other people. They'll call you many names, which I won't repeat on an audio file. Okay, so switching back over to my pointer, very carefully this time. And if I remove this, these are our 2 main pieces of measuring equipment. Well, if the capital A is an ammeter, that might give you away what a capital V is. It is in fact the voltmeter. So these 2, we're going to go into quite some detail on how to add them into a circuit. So if you get these wrong, they can either make the circuit not work, or you will be measuring something else that won't be important at all. Now, if we go down here, you would have seen this at key stage 3 or 4, and many of you would have drawn this incorrectly many times. You won't be the first or the last, and often people will draw this rectangle with a line going straight through it, which in fact is actually the symbol for a fuse, which is why they're side by side, and this one is a resistor. Okay, so it's a rectangular. Now, there are some other drawing conventions, so if you feel obliged to look at a circuit diagram, you might see a fairly standard resistor can be drawn like this, and they'll put a value over the top of it, so they might say 100 ohms, or they could do this to you, 2K2. Now, the reason they use the K, also occasionally they might do 2R2. Now the R in this one is because if I try to write on the side of a resistor, so let me draw a resistor, 2.2 ohms, be very easy for that little decimal point to go missing, and it would look like 22 ohms. So we actually put that R in just to make it obvious that it's a decimal point. The K is just like you've learnt in your prefixes. It means 1,000. So it's 2,000 plus 200. Okay, or 2,200 ohms. Again, it's just because we don't want to write out all the different numbers. We could have 10 digits, for example, which wouldn't be particularly useful when you see the size of some of these resistors. Okay, so battery, fuse. Fuse, we don't do a lot with fuses, but you do need to know the circuit diagram. Ammeter we've already talked about as a piece of measuring equipment. Now, these four on the bottom are our big hitters. These are the ones that will most often come up. So we've got our variable resistor. So it's like a resistor, but it's one that you can change the resistance of. It has a dial on it for the user, and we represent that dial with an arrow going through it. Okay. Now the one that looks like a hockey puck, and that's a good way of remembering it. So if when you draw this out on your revision material, please draw it, or even label it maybe as hockey puck to help you remember. And this is called a thermistor. So it's a resistor that, without giving too much away here, it's a thermistor, a resistor that adapts to thermal. So it's a heat sensitive resistor. So as the temperature changes, so does the resistance, which is really useful. Things that you'd be familiar with, like your computer that you're probably working on right now. As it works harder and harder, it gets hotter and hotter, well, there's a thermistor inside that measures that temperature. And you'll probably notice when your computer gets hot, the fan turns on. Well, the fan knows to turn on because there are thermistors in the circuit that says, oh, hang on a second, our circuit boards are getting a bit hot, we need some more air flowing over them, turn the fan up, please. Fan turns up, it cools down, and they go, thank you very much, you can probably back the fan down now. It's probably really noisy for the user. Okay, so that's a thermistor. You might often find those in cars as well. Engines, particularly engines in cars, excuse me, play an important role. An LDR. Now I'll write this out because often people will ask me about 3 weeks later, what's an LDR? It's a light dependent resistor. Okay, so it's a resistor that changes resistance based on how much light is coming on. Now the important thing here is these arrows are coming in. Okay, not to be confused with arrows coming out. So that's light coming in, that's light coming out. So if light's coming out, it means it's being produced or transferred as energy, which means we're looking at an LED, I know I'm going to write this down anyway, a light, where am I? There I am. Light emitting diode. Now, we used to have to teach diodes in GCSE, which would have made this next bit really easy. A diode is just a symbol. Oh, I've drawn it terribly. It looks like that. At A level we still use them. But a diode is essentially this bit inside here, and to make it a light emitting diode, it gets a circle drawn around with two arrows coming out. Okay, so the bit inside means that the electricity, the current can only go, or voltage can only go one direction. Right, so those are our 13 symbols. You need to know every single one of them, non-negotiable, and they need to be drawn around the side, down the side, across the bottom, don't care where, on your P10 revision material. Okay, so how we draw circuit diagrams. So if I get my pen here, this is what you would see if I gave you two bulbs, a few bits of wire, and you join them all together. Okay, but this is not a circuit diagram. This is this circuit diagram. Okay, now if you are very familiar, and I mean very, very familiar with series and parallel circuits, don't do this. Otherwise, this is the point in time where you draw this diagram, series circuit, And this is the same on the other side, a parallel circuit. So same two bulbs that we have over here, same battery. There are more wires, but effectively it's the same equipment, and it's just rearranged in a different way. Now the easy way to remember a series circuit, just to remind you, is there is only one path. There's only one way. It's like a racing track. Cars, the energy can only go one way, just like the cars on a racing track should only go one way. On this diagram, however, we have our energy can go this way, or our energy could actually go this way. Now they will all both meet back up here, for sure, but there are now multiple paths. Multiple paths means it's a parallel circuit. So please make sure you draw those on if you didn't remember that or you're unfamiliar with it in any way. Now, at this point of the lesson, I'd actually get you to make them. I'd actually give you the equipment and get you to make them. You'd have 6 minutes to do it. When you come back, we're going to obviously squeeze a lot of the practical components in. So make sure you have those two diagrams and you know how to make those two circuits without me having to draw them on the board for you. Oh, let's not run 6 minutes. That will take a while. Okay, so this is an example of a more useful circuit. So everything we showed you so far, so if I just quickly draw what we just did. So this is not a parallel circuit, it's meant to be a battery, a cell. Okay. That's really useful if I've got an endless source of batteries and I just want to have them on all the time. Okay, so if I connect this circuit up, my two bulbs will light up and they will stay lit up until this battery ceases to transfer any energy from chemical to electrical. So that might be simple in terms of GCSE, but it's not particularly useful in us learning anything. To learn anything, we need to start adding in measuring equipment. So some of the things we might use to measure, obviously we've already covered a voltmeter and an ammeter. Please don't call it an amp meter, there's no P in it, it's ammeter. And we might be still using the battery up here. This could be now bigger, or that could actually be two batteries. I'll just draw a bad battery in there. So we might increase the voltage in the circuit by adding a second battery. But we want to control the amount of current going through this circuit. And to do that, here's our introduction of a variable resistance. Now, it's fairly common to get a question like this drawn all out like this and saying, turn it into a circuit diagram. Now, it's very important you use a ruler. Okay, they will try, and one of the marks will be literally for drawing straight lines with a ruler. Now, if I just take the pen away for 2 seconds, I think the answer appears. So if you're watching this on YouTube, pause, see if you can go back to your circuit diagrams, your circuit components, and see whether you could draw your own version of this. And obviously if you're watching it on the SharePoint, you should be able to ignore my talking and click when you're ready, when you've had a go at it. But don't just skip through, actually have a go at it. So I'll reveal it now. So for the YouTubers, I'm pausing for 2 seconds and then I'll reveal it. Oh, and I've drawn all over the top of it up here, but you get the idea. So here are the labels of battery or cell, variable resistor. Now you'll notice it's a box shape, so rectangular shape. The resistor is labeled with an R, it doesn't need to be necessarily. An unknown metallic conductor, that could be anything. But it's something with resistance, so they label it as an R for resistance. And we've got a voltmeter. Now, really, really important here, guys. The voltmeter can't be in the circuit like a racetrack. If you put a voltmeter in the way, it has incredibly high resistance as part of how it works, and it will stop the circuit working. You'll be measuring nothing effectively. It has to be outside the circuit or in parallel. So this is now, there are two paths we could go. So if I switch to my pen for 2 seconds. Okay, so over here we could have energy flowing that way, or of course we could have energy flowing that way, and they will both join up back on the other side. So this side always in parallel, 1R, 2 L's. Okay, always in parallel. So voltmeters in parallel. Now the ammeter, by contrast, has to be in the circuit. Now, apologies, I've drawn all over the top of it. Okay, so your ammeter you put into the middle of the circuit. So it doesn't actually matter where you put it. Put it over here. Put it over here. It wouldn't make a blind bit of difference. It would measure exactly the same current. Okay, so here is the circuit that you made earlier. So there's two bulbs and our battery, and as you'll notice, all you're doing now is adding in the ammeter, you're adding it in series, and the voltmeter you're adding in parallel. Now, obviously we can't do that now, but when we return, I'll expect you to be able to set this up, get me a current off the ammeter, voltage off the voltmeter, and actually do some things with it. Okay, so concludes this lesson, guys. Although there's some stuff that's really will be familiar to you, there'll be some stuff that will be a bit of a, oh, I can't remember any of this, but don't worry. That's the whole point of this whole topic. Chapter 10, it takes some of the things you remember from Key Stage 3 and turns them into something that is actually measurable. You can actually understand more about electricity, how we use it, what voltage really means, what current really means, what power really means, and we'll talk about how that is in your home. So what's really valid to you. So it's going to have a context to it that's useful around the house, even if you don't have a huge, love of electricity and understanding all about it. You just want to turn things on, turn a switch on. That's fine, but it is always helpful to know. So why circuit breakers might trip out, etc. So there is a practical application to this, regardless of where you find yourself with the whole topic. Now, if you've been watching this on YouTube, you've got plenty of stuff to turn into your P10 revision resource. If you're watching it on as a PowerPoint off the SharePoint drive, obviously you could do a lot of cutting and pasting, but I would recommend you go back to the components, make sure you turn them into a P10 revision resource, and that is pretty much your lesson for this week. So there'll be 2 lessons for next week. Okay, they'll be a little tiny bit shorter than this one. But again, we're setting you up to make sure when we return, you can just get the practical components done. Otherwise, I am still waiting for suggestions for videos. We're now on electricity, and it happens to be I have some electrical primers available, or detonators. So I'd love some suggestions for your 10. What we could do is a little video. I'm a bit disappointed that not many of you seemed, what's the right word, enamored with my changing the tire in a wheelbarrow video. More views for the puppy chew toy. Fine, I accept this, but I want another idea for a video, guys, that you'll vote for. I need to beat Mr. Cleve. I've challenged him to who will look at more videos, him or me. At this stage, he's winning, and that can't stand. So let's have some suggestions via email. Thank you for those who sent them through. Be a bit more creative, be a bit more exciting, and I'll go and blow something up for you. All right, take care, and I'll see you all soon.